Yeah, hi guys. Last lesson we were looking at sketching parabolas based on their equations. We looked at a few different formats of the equation and how that affected the position of the parabola and in particular the vertex. So I've got a few notes here. You might want to pause and take some notes if you want. In the different formats, how those values affect that location of the vertex. Remember, the value of k translates that parabola vertically, so it moves that parabola up and down. The value of h translates the parabola horizontally, so left and right. We know that a, going back, dilates the parabola, so makes it wider or narrower, but also flips it so it opens upwards if it's a positive value of a, and opens downwards if it's a negative value of a. The vertex for each of these formats of the equation is given. So in the form y equals ax squared, there is no value of k or h. So there is no vertical or horizontal translation. The vertex is simply 0, 0. When y equals ax squared plus k, there is a value of k, therefore there is some vertical translation. The value of the vertex is 0, comma, whatever that value of k is. When we see a factorized version of the equation, so in the brackets, x take h squared, that value of h, like we said, moves that parabola horizontally left to right. So if it's a negative value of h, the parabola moves that many units to the right, and if it's a positive value of h, it moves the parabola that many units to the left. So basically the vertex is at the opposite value of h and 0, or the opposite value of h and k if there is a constant term after the brackets. So what we're going to do in this video is look at 4 equations, and we'll sketch those parabolas based on the location of their vertex and some of the other features, for example the y-intercept and axis of symmetry. So let's look at a simple equation in the form y equals ax squared. Let's see how that looks on a Cartesian plane. Got one here already drawn, so let's go with a pretty simple one. Y equals 2x squared. And how is that going to look just sketched roughly? We know in this form y equals ax squared. Okay, there is no value of k or h, there is no vertical or horizontal translation, the vertex is simply 0, 0. So we can mark that on our Cartesian plane right there. Okay, that's one of the important features to label as well, 0, 0 for our vertex. We've also spoken about the axis of symmetry, x equaling that same value of x in the vertex. So because in the vertex x value is 0, our axis of symmetry is also x equals 0. The y-intercept where it's crossing the y-axis here, well, that's also at 0, 0. And our x-intercept where it's crossing that x-axis, again, that's at 0, 0. So that's all pretty straightforward, but it only gives us one point to plot. So what we actually need to do is to, I guess, substitute another value into this equation to help us find another coordinate and roughly sketch that parabola. So let's go ahead and substitute x equals 1 into this equation. Keep it simple. So in that case, the y value is going to be x equals 2 times 1 squared, which is 1 squared is still 1, and 2 times 1 is 2. So another value on this, or another coordinate on this parabola, when x is 1, y is going to be 2. Okay, so we can go ahead and mark that point, 1, 2. We know the axis of symmetry is 0, which is this imaginary line that splits the parabola in half. We know a is a positive value, it's opening upwards. We also know that parabolas are symmetrical. In that case, I can actually determine that this here is also a point on the parabola. From my axis of symmetry, I'm moving 1 unit across to a point or a coordinate, so I can also move 1 unit in the opposite direction, or right or left of that axis of symmetry to create another coordinate. Once I've got 3 points, it's pretty easy to just go ahead and sketch a parabola, Try not to use a ruler. We want to see a nice curved line when we're drawing that parabola. Okay. The next one I'm going to look at is when there is a constant term, there is a value of k, so there is some vertical translation. So let's go ahead and look at another equation. Just on the page here. Let's use the equation y equals, let's do a negative value of a, so it's going to be opening downwards this time. Let's do negative, in fact let's do a fraction 1 over 2x squared, let's do take 4. Okay, so again, from this information we know that there is minus 4 is the value of k. We know there is some vertical translation. The vertex is going to be at the coordinates 0, comma, whatever that value of k is. So in this case it's minus 4, my vertex is 0, minus 4. We can go ahead and mark that in. 0, 1, 2, 3, 4 down. Axis of symmetry again, x is equal to the x value in the vertex, so x equals 0. My y-intercept, again that's the same as the vertex here, okay, where it's crossing, 0, minus 4, which is fine, but again, we've only got 1 point, so we need to come up with another coordinate to help us sketch this parabola. Again, we do know it's opening downwards, so there's not going to be any x-intercepts in this case. So, let's go ahead and substitute. Instead of 1, let's do x equals 2 this time. So we can do y equals minus a half times by 2 squared, take 4. Okay, which is equal to minus 1 over 2 times 2 squared is 4, take 4. I'm now left with minus a half times by 4, take 4. Order of operations, I'm going to do this first. Minus a half times 4, so half of 4 is 2, minus times a positive is a minus, so that becomes minus 2, take 4, which is minus 6. Okay, so another coordinate on this parabola, when the value of x is 2, the value of y is minus 6. So let's go ahead and mark that coordinate, so minus 2, positive 2, 1, 2. Minus 6, 1, 2, 3, 4, 5, 6. Again, my axis of symmetry is 0. I know it's curving downwards because a is a negative value. So again, understanding that parabolas are symmetrical, I can also mark a point here, 2 units to the left of that axis of symmetry, because I know this coordinate is 2 units to the right of that axis of symmetry. And just a nice curved line. Done. Okay, we look at 2 more. Next we're going to look at an equation in the form of y equals a x take h all squared. And there is going to be, in this case, some horizontal translation. So, let's look at the equation. Y equals x take 3 all squared. Okay, and as we said earlier, that value of h, in this case it's minus 3, determines the horizontal translation of the parabola. Because it's minus 3, okay, the parabola is actually going to translate 3 units to the right. Okay, so my vertex is going to be the opposite value of minus 3, which is positive 3, and 0. So vertex 3, 0. Let's go ahead and mark that point in our Cartesian plane. 3 right there. Again, your axis of symmetry is x equals 3, the same value of x in the vertex coordinates. I'm not sure where it's crossing the y-intercept yet. Alright, so in this case, my vertex is not the same as my y-intercept because of that horizontal translation. So what we need to do is to substitute the value of x being 0 to work out where it crosses the y-intercept. So let's substitute x equals 0 to determine where this parabola crosses the y-intercept. And again, there is no value of a here. We assume it's a 1. It's a positive 1 because there's no negative sign. So we know it's opening upwards. So let's substitute 0 into this equation. Y equals, instead of x, we've got 0. Take 3 all squared. 0 take 3 is minus 3 all squared. Minus 3 squared is 9, which gives me a coordinate 0, 9. So when x is 0, y is 9, that's also my y-intercept. Go ahead and mark that on. 1, 2, 3, 4, 9. Y-intercept 0, 9. Again, this is my axis of symmetry. Positive 3. Either side of that. 1, 2, 3 units to the left. 1, 2, 3 units to the right would be another point. So knowing those 3 points, I can go ahead and sort of sketch my parabola like so. And this time it is crossing the x-intercept at positive 3, 0, same as the vertex. Okay, last equation we're going to look at is in the form where we do have a value of h and a value of k, so there is some vertical and horizontal translation. But that also makes it a little bit easier for us to identify where our vertex is going to be too. So let's start fresh. Let's use the equation y equals x, let's keep it simple, plus 2 squared, let's do plus 1. Okay, so based on that, my vertex is going to be the opposite value of h, which in this case is positive 2, and the value of k, which in this case is 1. So, opposite of positive 2, negative 2, the value of k is 1. That's my vertex. Let's go ahead and mark that on our Cartesian plate. Negative 2 and positive 1, negative 2, positive 1. Axis of symmetry, I know, is our x value in the coordinates of the vertex, minus 2. My y-intercept, that'll be good to know to help me sketch this parabola. So obviously to do that, we're going to substitute x equals y, sorry, x equals 0 into this equation. So, I'm going to say guys, 0 plus 2 all squared plus 1. 0 plus 2 is 2 squared plus 1. 2 squared is obviously 4. Which gives me a value of 5. When x is 0, y is 5. That's my y-intercept. Okay, I can go ahead and mark that. 1, 2, 3, 4, 5. Again, this is my axis of symmetry. 2 units to the right is a point, so 2 units to the left would also be a point. And once I've got that, just go ahead and sketch in a nice curved parabola. And there you have it, guys. Again, notice here it's not crossing the x-intercept, so there's no values there to identify. Okay, I hope that helped. Thanks.